We often think of our spacecraft a bit like, family relatives or children or something as we send them off into space. It's a little bit like putting a mobile phone in a drawer for 5 years and then taking it out after 5 years and expecting it to work. You've really got to be very confident that your instrument is operating, because that's the last time you're going to see it in your lab.
Bepi Colombo aims to study the origin and evolution of Mercury, the least explored planet in our solar system. It will investigate the planet's form, structure, and surface composition, giving us clues on how our solar system was formed. The Mercury Imaging X-ray Spectrometer, MIX, will measure the charged particles emitted from the day side of the planet. The instrument will also study Mercury's magnetosphere and explore the dramatic interaction of the planet's surface, with anticipation of seeing an aurora like this on Mercury. But why is this research important for life on Earth?
We inhabit a planet. We live on a planet with an atmosphere. We live inside a magnetosphere. Understanding how space weather works, so how the sun controls our immediate space environment, that magnetosphere, is then really important, because it affects the space infrastructure that we're relying on. Our GPS in our cars is relying on the accuracy of that positioning system. And if you have a solar storm that upsets the upper atmosphere of the Earth, you can change the accuracy of that positioning system. So studying it in the most general way that we can, by studying different planets in the solar system, I would argue is really very important.
The aurora is visual evidence of a magnetosphere in action. It is caused by particles from the sun hitting the Earth's magnetic field. Gases in the upper atmosphere interact with these particles, causing it to glow.
It can be quite abstract, trying to understand something like space, plasma physics, or magnetospheric physics. What does it mean? Why do we care? And actually that is a really visual way of showing somebody, A, something beautiful, but B, something that really is important for us to understand.
Mercury's magnetosphere is very weak and is strongly driven by the sun's magnetic field. Seeing an aurora on Mercury with the naked eye is virtually impossible.
We're going to be able to use MIX to look at the X-rays coming from the night side of the planet. What we expect to see is almost like auroral bands in the north and the south. So I'm personally really excited about that, because I enjoy studying magnetospheres and the aurora. And this is as close to an aurora as you're going to get on Mercury. It's the interaction of charged particles with the surface of the planet. On the face of it, you think we have a set of planets that have seemingly similar situations. What we learn is that they are all different. All the magnetic fields are different. Each of them raises questions about how they were generated and how that compares to the Earth. All of the atmospheres are different. The magnetospheres work in different ways. That you think something looks similar to your own planet, but then when you actually go and measure it and take lots of information and gather new data, what you find is that it is actually very different to the way our own system works.